My name is John McKeon, and I'm the moderator for the Teradata Aprimo River community, Teradata and Aprimo's largest customer community. You can connect with us at TeradataRiver2.com. We're speaking with Sam Freesemeyer, Director of Engineering for a very large company, AGCO, which actually builds a tremendous amount of tractors and farm equipment around the world. I think it is 140 countries, huge manufacturing base. He will be presenting at this year's Partners Conference on AGCO Corporation's Telematics and Data Warehouse Proof of Concept for Teradata 14. Welcome to the River, Sam.
Thanks, John.
Sam, we had been talking earlier about AGCO being a result of many different acquisitions. So you have all of this different operational data and all of this different types of data. How has the new environment that you've been testing actually helped with this diversity of data?
Well, John, the problem we're looking at is, as you may know if you've followed our company, we're a company that's grown by acquisition for a number of years. And so we're a large global footprint made up of essentially 26 different companies that have been brought together. Today we have 14 major engineering sites around the world, addressing the task of designing farm equipment in about 9 different languages in different continents and countries. So the challenge is, how do you manage such a thing? The industry that we serve, the agricultural equipment industry, is not large enough for us to go out and design a unique tractor for each site. So we tend to use a lot of platform-based design and try and use the synergies of the skills of our engineers in various sites to develop different parts of the tractor and then put them together to try and find the best combination. The challenge that comes from that, each one of our sites has grown up differently based on its own unique culture and history, and so the information systems that run those sites are all different. In most cases, they are cross-functional management organizations where we have representatives and systems serving engineering, product management, marketing, finance, manufacturing, product support. And so as you start trying to manage an engineering team across that kind of diversity, what you find is none of the data systems match. None of the data systems even really present all of the same information or put it in the same format. So you might say, well, great, why don't you just put in a new system and replace all those old systems? The problem with that is that you just can't replace a major management function within a site like this without creating tremendous havoc. You have to kind of take the systems little bites at a time. But you also got to keep managing the business while you're trying to do that. And so the challenge to us is, how do you get commonality in the data that we look at to try and manage the business and to provide that sort of an oversight function across all these various systems so that you can then over the next few years, step by step, piece by piece, go in and start replacing the fundamental pieces underneath. That's when we started looking to the Teradata system to be able to give us that top view and the ability to dive down into the data and put it all into a format that we can use, buy us the time basically to start changing over some of the lower level systems.
Sam, give me some idea as to when you're doing your proof of concept, you had to go out and figure out what data you needed and process it and actually kind of do a proof of concept. What was the timing in this, and what maybe were some of the surprises that came out?
It was interesting to say the least. We had looked at the Teradata product, at the software and the hardware that ran it, and the capabilities to move lots of data, so we definitely wanted to try and exercise the system, make sure that we knew that it was going to be able to handle the amount of data we wanted to throw at it. We actually chose an engineering example that got us some of the biggest data sets we could find. We chose 4 data sets: the complete PLM system, the content of the attributes on our 3D CAD files, made up about 3 million rows of data of indented bill of material structure through which we could search to try and find a particular part. We brought in a year's worth of warranty data, which was another 60,000 rows. We brought in a correlation file that matched engine to transmission, which would have to pivot through that to get from the warranty data to the 4th file, which was actually a telemetry file. And the telemetry file had 210 million rows of data, went back about 10 years. And so we spent a long time trying to figure out exactly what would give us the ability to exercise the system without necessarily making a career out of this. This was, after all, a proof of concept. We actually ended up spending about 10 months before we finally came to an agreement on the data sets we wanted to use and how we wanted to process them to make sure that we could actually see, does the system do what we wanted it to do. Like most typical engineering projects, you got so long to get the project done and you spend most of your time debating which way to go after it. And in the end, we'd only left about a week or two to actually get the work done. After 10 months of deliberation, we spent another 2 weeks collecting the data sets and getting those staged and ready to go. And then Ralph and his team came in and processed the data for us in about 4 days.
That's amazing. A long stretch from the Excel processing, right?
Yeah, we might have still been at it in the old Excel spreadsheet approach.
Well, it's interesting, Sam. You have all these machines out there. You mentioned warranty data. What about drawing the live telemetry data off these machines? Tell me about what that looks like from a data perspective.
We've had a product out in the market. It's actually been flying under the radar for a few years, but we've started pushing it in the last 3 or 4 years. It is a fairly state-of-the-art product that we offer, but it's a wireless modem, basically, that's wired into the CAN bus of the tractor and listening for certain data types and monitoring where the tractor is in the world. And it's got a GPS built into it, and it's got a cellular modem built into it. And it just logs data off the tractor once per second. And then every 15 minutes or so, it fires up the modem and sends a burst of data back to the internet and stores it on a file. And this telemetry system, we've had it on several hundred machines running for, I think we had like 10 or 11 years worth of data in the file. It's a product we offer, but what we wanted to see is, could we really dig out problems on a tractor from the telemetry data? So to do that, we're going to have to be able to match this continuous stream of data coming off the tractor with a real live failure, something that we know went wrong, and then see if we could draw any conclusions from that.
Give me the size of these tables and these lines. What kind of data are we talking about?
The parameters we're looking at, as we set up a machine, there might be, 30 or 40 different parameters that are going to be logged every second. And each class of machine, each type or model of machine has a different set of parameters that we're interested in. So over this whole table, 210 million rows of data, there were over 220 or 221 tables inside this data structure. Now, we had no clue until Ralph and the guys went through it, came back and showed us what was in the data file and how it was structured. This is actually a system that's been developed several years ago. But we started sorting through it and we said, wow, there's a lot in this. That's kind of the size of it. By the time we finished combing through the data set, I guess we knew a lot more about our data than we thought we did.
Sam, you talked about having tractors all over the world. You talked about having manufacturing facilities. And I think probably one of the biggest things is, how do you coordinate the information from these different manufacturing facilities and engineering facilities around the world from a data perspective?
Poorly at the moment, I would have to say, but we're looking at data sets. And as we want to try and get commonality in our understanding of what's going on in the projects at each site, we tend to bring a lot of stuff into spreadsheets and just crunch it down and then have to go back and find out what the numbers mean. And it becomes a sort of a grueling, daunting task to do such a cross-site analysis. We can't afford to do it very often. We just don't have the time or the manpower to get it done. So what we're looking for is ways to bring the data in front of us in a consistent format, as opposed to processing the analysis in spreadsheets on the fly every month. It's just not reasonable. And so we're looking for a means to get that data transformed so what we're looking at is a consistent data set across all of our sites.
And will that be a reality in the future?
Yeah, oh yeah, very much so. As we look at the data sets, we know how to crunch the data. We've done it in spreadsheets in small doses. It's just you're limited to so many tens of thousands of lines in a spreadsheet, and then how patient you are waiting for the thing to recalculate and copying all the calculations down. It's just not reasonable. We know what we want to do, but we haven't really had the horsepower to get it done up until now. I think that's one of the things about the proof of concept that we did. I'm glad that we threw a real challenge at them to see what could be done. It's got us a little bit excited about it now in terms of saying, hey, this number crunching dilemma that we've been facing has a potential light at the end of the tunnel. We can see a way to get this done.
That's great. Sam Freesemeyer, Director of Engineering for AGCO. Should be a great presentation at Partners Conference to actually look at a global organization with massive data, massive engineering centers all over the world, and be able to hear the stories of what happened when they did the proof of concept and what were the outcomes. Sam, look forward to seeing you at Partners this year.
Thanks, John. I'm looking forward to it myself.